Hi students, welcome back to the video tutorial series. This is tutorial number 4 and today we're going to be looking at how to build a program that runs a maze puzzle. So let's get straight into it and take a look. Okay, so today we're going to be looking at this project here, and this is my project for a maze puzzle game. I have a character down at the bottom here, which is an elephant, and the elephant has to get through the maze and reach the objective at the top, which is the bananas. So let's give it a quick go and see how this runs. You can see that the elephant navigates through the maze effectively, and if I keep pressing right or left, the elephant does not move through the walls of the maze. Looks like we found the route through. The elephant gets the bananas. There's a big cheer, everybody's happy, and we have some speech output from the elephant. And that's it. Now you can see that the elephant is reset right to the back of the beginning of the maze, and now the maze is different. Let's see if we can do level 2. Okay, fantastic. So, here we have the code for the elephant, the maze, and the bananas. Now, this is going to be pretty much the same as the other tutorials so far in terms of how we code and the logic behind what functions we put together. But the addition this time is that we have this maze, which is a sprite, and this has been imported from an external source. Basically, if you wanted to, you could sit down and use the drawing functionality within Scratch, and you could draw your own maze by hand and then import it as a sprite and then give it some code. But to save some time on this project, we are going to use a ready-made maze, and we can see from underneath the costumes that we have a total of 8 different types of maze. So this gives our project a total possibility of a maximum of 8 unique different levels. So the first thing that we need to do, as ever, is to start with the blank project base. We've got the cat in the backdrop, which we do not need, so let's get rid of the cat. And the first thing that I'm going to do is to choose a backdrop. So I'll keep it exactly the same as my example for the purposes of clarity. My backdrop was jungle because the elephant is going through the jungle to get the bananas. So now we have that in place, we need to start thinking about importing our sprites. So let's start with the maze sprite. For this, it needs to be stored on your computer somewhere. So I will give you the file for the maze, and then you will be able to upload it into your project. So to do this, we go to the sprite menu at the bottom, choose a sprite, and we want to use the top button here, which is upload a sprite. Now this is going to search my computer for the correct location of the file that we need, and I'll make this easy for you on your computer, so don't worry. I just need to go into my documents. this is where I keep all of the maze software. Now we can see we've got maze 1, 2, 3, 4, 5, 6, 7, 8, and a picture of the maze code in here. And we've also got this little file here, which is called maze.sprite2, and this is the one that we need to load into the Scratch software. And when we load this in, it will bring all of these mazes in with it as costumes. So we just select maze sprite 2 and go to open. You can see it's importing, and now the maze is here. Perfect. So the next thing we need to do is choose the remainder of our sprites. I've got an elephant and I've got some bananas, because elephants love bananas. There's our elephant, and there's our bananas. Now, as you can see, the current situation is that the elephant and the bananas are obviously far, far too big to run through this maze. So we need to shrink them down using the size functionality to a more suitable size. And I think 20 is about right for the elephant. I'm just going to move him here. Maybe he needs to be a bit smaller actually. You can see that he's overlapping with the walls of the maze. It's very important in this project that the elephant is small enough, or the sprite is small enough, whichever you choose, to fit into the gaps, into the alleys of the maze without touching the sides, because this will prevent your code from working properly. And that looks about right. And the bananas. Put the bananas at the end point here. That's where I want them to go later. So, what do we need to think of in terms of this project? We need the elephant to move through the maze. He needs to be able to move forwards, backwards, up, down, left and right. So he needs to be able to move along both the x-axis and the y-axis, horizontal and vertical. The maze needs to not do too much, it just needs to be there. But the walls of the maze need to prevent the elephant from being able to pass through, otherwise he'd be able to cheat very easily, go straight to the end, and that would be no fun for anybody. And finally the bananas just need to stay in position and wait for the elephant to come and eat them. So let's have a look at how we build this. Let's start with the maze. Actually, let's start with the elephant. So, here is the code that I've got for the elephant, and you can see it's quite long, but don't worry, we're going to go through this piece by piece, and it will make sense to you, I think. And they will also obviously be able to reference and access this tutorial as many times as you wish on YouTube. So if you do have any problems, you can take a look at it over and over again, and you can also come to me for some advice. So our elephant is a total of 2 different sets of code. And we can see that both sets of code are activated by the same event trigger when the green flag is clicked. The first set of code, this here, refers to the actual movement of the elephant through the maze. And this code here refers to the elephant finishing the maze, getting to the bananas, and what happens when the elephant gets to the bananas. He needs to be able to go back to the beginning of the maze so you can start the next level. And you don't want to do this manually, you want this to happen automatically, and that's what's going to happen here. But first we look at the functionality of the elephant moving through the maze. So, You can see here that we start with when the green flag is clicked. We want to set the size of the elephant to 8%. And we also want him to go to what's called the front layer. Now, this is just to make sure that the elephant is visible in front of any other object in the stage at any one time. So he cannot pass behind things and disappear. He's always in the front and visible. Next, we have the go to x 10 and y minus 170. Now, if you look at the bottom here underneath the backdrop and the stage, you will see that this is the coordinates for where the elephant is currently positioned. So when I click the green flag, the elephant should automatically change size so that he's the correct size to move through the maze. He should automatically be at the front top layer of the stage so that he cannot pass through any object and is visible at all times. And he should also move to the correct coordinates into the correct position so you can start. Next, we have this big chunk of code here. You can see that these different sets of code are all very similar. And they are all inside a forever loop because we want the elephant to do this forever. But before we get to that, I'm just going to code in this little bit of code here so that we build it as we go along and you can test and see the functionality of any changes that we make as we progress. So, first, events. An event trigger when the green flag is clicked. Looks. Set size to 8%. And looks, again, we're looking for a go-to tile. There it is, go-to, and front layer is already selected for you. If you have a look in here, the drop-down menu, it's only front and back because they're the only two options that we have in this current project. If your project had many, many different layers, you would be able to choose for any given sprite to operate on any given layer that you desire. So if you wanted a sprite to move behind some objects, maybe to hide behind something in a game and avoid bullets, then this is entirely possible on Scratch. So we want him also to go to the correct coordinates. Go to X and Y, and the coordinates that we want him to go to, what did we say that they were? It's already set to where he currently is, so this is fine. 13 Y170. So, next we need this forever loop. This is under control. It controls the behavior of the sprite. So all of the actions that we want the elephant to do inside of this, we want him to keep on doing until the project actually finishes. We don't want him to do them once, we don't want him to move up once and then finish and not be able to move again. That would be useless. We want him to be able to move up as many times as he needs to, all the way through. And you can see all of this code is very similar because all of this code is just to control the direction of the elephant. This first bit here is if the key up arrow is pressed, then change the y-axis by 4. So we want to change the y by a positive value. The y-axis is the vertical axis. Positive along the vertical axis is up or north. So this will mean that every time that the up arrow is pressed, the elephant will move 4 paces north or up. And the next bit that we have relates to the elephant touching the maze. So, As we said before, we don't want the elephant to be able to pass through the walls. This would be pretty useless in a maze puzzle game. So this little bit tells us that if the elephant is touching the maze at any point when he is moving up, then to change the y value by -4. So if he moves up here and he hits the wall, this bit of code will stop him from going through the wall and he will just stop where he is. And we've got this repeated many times for up, down, left and right. And you can see it's exactly the same in every instance. The only difference is in this top block here, we have the different key up, down, left and right. And the only other difference is the coordinates, because if he's moving down, the first box needs to be -4, to be changed at +4, and as we just saw, if he's moving up is the opposite, so you would change the y by 4 to move up and change the y by -4 if he hits the wall. So let's go and take a look at coding this into our project. So, sense. We want the project to be able to sense an action, something is happening. We want it to sense that if the key is pressed, so we need if. If the key is pressed, then do something. So we want, if the up arrow is pressed, we want some motion. We want him to move along the y-axis by +4. Change y by 4. And we also needed another if at this point, because we have if he's touching the maze, then change y by -4. And you can see here that this if statement, the second one, is attached to the change y by 4. It's not directly underneath the original if statement. It's inside of it. And this is very important when you are coding, because putting the if in 2 different positions will mean 2 different things in your code. Everything in programming and coding is exactly precise. This is why there is lots of mathematical functions, because it's all built around mathematics. And mathematics is either correct or it is incorrect. There is no ambiguity. So if you put things in the wrong place, it's very, very likely that some or all of your code is going to fail to run exactly as you would like it. And you might get some errors or some bugs which you then have to go back and try and fix. And this can be very problematic. It takes a lot of time. It's hard to look through lots and lots of code to find one little mistake. So it's much easier just to be very careful at the very beginning and try not to make any mistakes and check your code is going along. And that's what we will do in a moment. Once we finish building this little bit of code, we will run the program and double check that everything is working as it is before we continue. So we need if we're going to touch the maze, and we need this top sensing block here if the elephant is touching, and we have the maze in the drop down menu because the sprite is already in our program. We need to change by -4. And again, you can go up to motion here to change by -4, or you can duplicate this +4 block, slot it in, and very importantly, make sure that you change the value of y to the opposite, -4. So let's see how that works at the moment. I've clicked the green button, and now I'll press up, and you can see that my elephant moved up. I'll make it bigger for you. I press up, He moves up, and I'm still holding up right now, and you can see that he does not pass through the walls of the maze of the wall. And if I press left and right and down or any other button, nothing else happens in this program right now, because all we've told the program to do is allow the elephant to move up and not be allowed to pass through the wall. So, now that we need to input the functionality for down, left and right, and since it's pretty much identical as a series of if statements, we can just duplicate the code that we've previously made in order to save ourselves some time, and we're going to do that 3 times for up, for down, left and right rather. Sorry. Okay, so now we have 3 more instances of the same code, and this is very good at practice to do this, because not only does it save you time, but if you know that the first set of code works fine and you're duplicating the code, then this code should also all work fine, and it saves you the potential for running into any unknown manual errors by accidentally clicking on the wrong thing or inputting a wrong value. So we need to put this in. Let's put these if statements into the forever loop, and we do this just by attaching it to the bottom of the other if statement. Now these are separate if statements. They want to be on the outside just here. They need to be inside only the forever loop. If they're inside anything else, then this is incorrect. So just be very careful, make sure that it's only the forever loop that they are being input into. Okay, and I've got one extra one here which I don't need, so I'm just going to delete that. Now let's go through. We've already got when the up arrow is pressed, so let's change the values here. When the down arrow is pressed, change y by -4, because -4 moves down along south along the vertical y axis. And if he is touching the maze, then to stop him moving through the maze, we need him to reset his position by 4. And exactly the same for left. Left is west along the x-axis, and the further west you go, the further left you go along the x-axis, away from the middle, these numbers increase in minus values. So we have -4, and if he's touching the maze, reset by 4. And finally, the same functionality for right, but the y-axis this time from 0, he's moving +4 every time the button is pressed, and change to -4. And again, we can test this to see and double check that our code works as it should. So let's have a look. I'm going to move up. Perfect. I'm still holding up. He's not moving through the maze. I need to move left. And this is not working. So you can see that there's a little problem with the code. And you can see what I'm hoping you can see what I've done here is another thing for you to be very careful of, because we duplicated the blocks. Now all of the blocks where it says change by are all Y. You need to make sure that you switch these blocks out so that they represent the appropriate value for X or Y, depending on whether you're moving up or down and left or right. So up and down are fine because they should be moving along the Y-axis, but for left and right, Y is useless to us. So we need to change X. In this instance. bring x in and duplicate it as many times as you might need it. Okay, so now you can see that we have for up and down, we have the y values in place, and for left and right, we have the x values in place. And I can't stress enough how important it is to make sure that all of these values are double checked and are correct, because this is essential to the correct functionality of your program. So let's run that again and double check that everything works as it should. And again, I can't stress enough how important it is for you to constantly check your work as you go along. Even if you check every little change, it's much better to do this and avoid any mistakes than it is to get to the end and have an error and not be able to find it because you've got lots and lots and lots of code and it's very confusing to read. So I press up, elephant moves up, he doesn't go through the wall. Press left, he goes left, he doesn't go through the wall. Down, he moves down, doesn't go through the wall. We have to go left again and up again. Right, you can see it's the same functionality. The elephant is now moving through the maze effectively. And at no point in the maze, because all of the walls in the maze act as one sprite, there's no point in the maze now where he's going to be able to pass through the walls. But currently, when he gets to the end and achieves his objective, nothing happens because we haven't coded that yet. And you can see I've stopped the project. The elephant is still at the top. And again, we need to code that in, and that's going to be the next thing that we do now. So, let's take a look at our code for the elephant, the second piece. This is based around another forever loop because we want this to happen all throughout the entire of the project. When the green flag is clicked, forever, if the elephant is touching the bananas, then play a sound which is cheer, and I want the elephant to say yay bananas, yum, for about 2 seconds on the screen. And then I want him to return to his original coordinate position so that we can restart the next level. And this little bit at the bottom is a new piece of functionality that I haven't shown you yet. This broadcast block is basically how different sprites in a program communicate and talk to each other. So this is going to tell, the elephant is going to tell the maze at this point that he has completed the maze. He's returned to his original position, and he needs the maze to change costumes so that he can start the next level. And we're going to go through how to do this, and this is an extremely powerful tool in Scratch and in software generally. Very useful for programming for many, many different applications. So, let's go ahead and build this. We go back to our elephant window, and always make sure that the elephant is showing the sprite that you want to edit, and code is showing in the top right hand corner here, or you can see that it's selected here. So we want, when the green flag is clicked, a forever loop, and then an if statement. Because all of the if statements are inside the forever loop. If something happens, then do this forever. If the elephant is touching the bananas, bananas are in the drop-down menu because it's already operational as a sprite in our project. We want to make a cheering sound, so play sound cheer for 2 until done. So this means that the cheering will continue until the next level is ready to go. We can see in the drop-down menu that cheer is not an option because by default in the costumes you will see that the elephant only has pop as its sound, and that's pretty useless to us here, so we'll just go ahead and delete that and change it to cheer. Okay, so there it is. We have the cheer sound loaded into the elephant sprite. So now when we go back to our code and go to the play sound block, click the drop down menu, and cheer is now on. Perfect. Then we want him to say, "Yay, bananas, yum," for 2 seconds. And because this is only going to be text on the screen and it is not going to be actual audio, it is under looks and not sound. It's just going to display some text. Yay, bananas, yum, for 2 seconds. And then go to the original coordinates and broadcast the next maze. In motion, we look for the go to block. But we don't want to go to, we've got to go to X and go to Y. And we want these coordinates here to be the same as they are here. This is how you will know they are correct. They should always be the same because this is telling the elephant to go here at the beginning of the project, and this is telling the elephant to return here at the end of the project once he has reached the bananas and is ready to start the next level. Okay, now on to the broadcast. Broadcast is an event, and as I said before, it's a communication tool. It's going to allow my elephant to talk to the maze. At the moment, you can see we only have new message. There is no other option, and we will see why in a moment. Here, you can see on my finished project, we have next maze as the variable. And on the maze itself, you can see that we have these set of coordinates, these set of instructions here. So, we are finished with our code for the elephant. We have all of the instructions of how to move here, and here we have the instructions telling him what to do and where to go once he has reached the bananas and completed the level. So, now that the elephant is complete, we will code the maze. You can see here that the maze has 2 very simple sets of instructions. The first instruction is that when the green flag is clicked, that it should show costume 1, maze 1. And that is this design of this maze here. And here we have go to X0, Y0. As I told you before in an earlier tutorial, x0, y0 coordinates are the very center of the stage, around about here. And because the maze is a perfect square, equal sides, if we set the coordinates to x0, y0, this means that the maze is perfectly in the center of our screen. The gap here is the same size as the gap here, and this line is along the bottom border, just like the top line here. And this bit relates to the broadcast. And this says, when I receive a message from the elephant telling me to change the maze costume to the next maze, ready for the new level, select the next costume. And it really is that simple. So, let's choose our maze, and we have the first set of code, which is an event trigger when green flag is clicked. Switch costume to maze 1 and go to x0, y0. Show the first maze and make sure that the maze is always in the center of the screen. If the maze moves around, then the elephant is not going to be able to navigate the maze. And if it's not at the center of the screen, it's not going to look very pretty. So, important for us to be professional. Okay, so when we have the control, when I receive the message to switch the maze, and this is a visual thing, just next costume. Now we still got message 1 here and message 1 here. What we need to do in the elephant is change this message to new maze. You can name it anything, but this makes sense. This is what we want it to do, and it's very important in programming to avoid getting confused that we make sure that we give things names which make sense and are logical, so that it makes it easy for us to read back the code later. As we've gone through these tutorials, I've been showing you the code, and I've been trying to explain it to you in English like a story. First we do this. When this happens, this is going to happen. After this happens, this happens. A, B, C. If A, then B, or if A, then B and C. And sometimes this is in a forever loop. When this is clicked, do this particular thing forever. And if you think of code in this way and try and write it out and plan it in English first, just like you would write a story, thinking about the beginning, the middle and the end, and all of the different things that have to happen in between in order for the story to go somewhere and to read properly and to make sense. If you can apply these principles to coding, you'll find coding much easier to understand and to be able to do. Okay, so the last thing that we've got to do is code in the banana code. And looking at this on my example, the bananas code is also very simple. When the green flag is clicked, set the banana size to 20% of the original size. Remember when I loaded in the banana, it was way too big for the maze. And I established the 20% was the right size. It makes it about this size. And finally, go to x minus 10, y 170. And that is exactly this position here, as we can see at the bottom. So, when green flag is clicked, the banana should shrink in size to 20% of its original size, and it should go to the position in the maze that we want, which is coordinates x minus 10 and y 170. So let's put that in for our bananas. I go to X and Y. Okay, and these coordinates are the same here. He's in the right position. So, now let's run our program and see what happens. I'm moving up, he won't go through the wall. Right, he's fine. You can see the elephant is moving perfectly fine through the maze. It's taking a very long way round. Complicated maze. But eventually we're going to get to those tasty, tasty bananas. And we will see the rest of our code. There is the cheer. There is the text, yay bananas yum. The maze has changed to the next level. And the elephant is back to the beginning, ready to start again. Perfect. I hope this was very easy for you to understand. Do not worry if you are struggling to understand this at the moment. I will give you plenty of help and assistance in the tutorials and in the ECA classes. And you can watch them as many times as you want. And you can ask me as many questions as you want as well. Do not be afraid to be wrong or to do things incorrectly. Because by making mistakes, this is how we learn. If we do everything perfectly all of the time, then we do not learn anything new. It would be nice to do everything perfectly every time, but this is not reality, unfortunately. People make mistakes, and hopefully people learn from the mistakes, and we grow, both as students and as people. So, in the next tutorial, I think we will advance on these concepts a little bit more, and we will use the maze again. But next time we will make a two-player maze game where two different characters will race each other through the maze to reach an objective. And it's going to be very similar to this one, but it's going to introduce one or two new principles. And slowly we will keep doing this, introducing one or more two things each time, building up your knowledge of the software and your understanding of what you need to do in order to make your own changes and your own projects. Okay, that's it for now. Have a great day.